So far we've been talking about the arrangement of the periodic table based on the chemical properties of elements, properties like reactivity. The periodic table also divides elements into three categories based on their physical properties. Properties like luster, how shiny something is, malleability, whether it can be formed into sheets, and conductivity of heat and electricity. All of the materials that surround you, the objects you use, the air you breathe, the ground that you walk on, even your body, are made of elements and compounds. The location of each element in the periodic table is based on its properties. One of the ways the periodic table groups the elements is to separate them into metals, nonmetals, and metalloids. Go ahead and pause the video and write the essential question in your notes. Metals are on the left and lower side of the periodic table. They're represented in blue here, and notice that more than 2/3 of the elements are metals. They include elements such as aluminum and gold. Most of these elements are shiny. They can be molded and shaped, and they can conduct heat and electricity. All nonmetals, except hydrogen, are on the upper right side of the periodic table. They're represented in green. Nonmetals are elements such as helium, oxygen, and bromine. These materials are either gases, like helium and oxygen, or brittle solids, like carbon and sulfur. They have properties that are much different than the properties of metals. For example, nonmetals are not easily molded or shaped, and they're not good conductors of heat or electricity. Even bromine here, which is the only liquid nonmetal on the table. A diagonal line of elements, here they're in orange, represents the metalloids and separates the metals from the nonmetals. The metalloids, elements like boron, silicon, and antimony, have some properties of both metals and nonmetals. We'll remember in this class where the metals end and the nonmetals begin by memorizing the metalloids. All you have to do is remember that boron here is a metalloid. Then go to silicon, and down and over, down and over, down, and you're done. It's easy. Remember that hydrogen over here is the only exception. It's a nonmetal, but it's in group 1A because of its one valence electron. If you ever get really confused about which one's which, what side is metals, which side is nonmetals, just start looking at element names. Metals like iron and titanium are on the left, and you know that these are metals. Nonmetals like oxygen and nitrogen over here are on the right. Imagine that you have two different objects that are both made of metal. A metal frying pan and let's say a piece of copper wire. What properties are similar between these two objects? They're both metals and they appear shiny. But the frying pan, the wire, and most other metals also share other properties. Let's take a closer look at the common physical properties of metals to determine how you can distinguish metals from the other elements. Let's start with luster. Most objects made of metal are shiny in their appearance. Some examples are aluminum cans, silver coins, or silver or gold jewelry. Malleability is also a property of metals. Most metals can be molded or stretched into sheets when they're heated. They can form many different shapes. For example, the metal aluminum is very malleable. It can be hammered into thin sheets of aluminum foil. Most metals are also ductile. That is, they can be pulled into thin wires. Think of the spokes on a bicycle wheel. Another property of metals is conductivity. Heat and electricity flow easily through most metals. In other words, metals are conductors of heat and electricity. A frying pan is made of metal because the heat from a stove can transfer through the metal pan and cook the food. An electric wire is often made of copper because the metal allows electrons to flow through the metal wire. Nonmetals have properties that are different than metals. Imagine that you have two different objects containing a nonmetal. A sign filled with neon gas, like the bright orange signs that you see on business fronts, and a piece of carbon, like these. At first glance, these objects don't seem very similar. but they do share some properties. Let's take a closer look at those common physical properties that nonmetals possess to determine how we can distinguish them from other elements like metals. Objects made out of nonmetals are usually dull in their appearance, like this sulfur over here, a yellow solid, or these carbon nuggets, like the charcoal briquettes that you put in your grill. Nonmetals are usually more brittle than metals. That means they can't be molded or stretched into a wire the way that metals can. If you were to drop a nonmetal or strike it with a hammer, it would likely shatter into a bunch of small pieces. Many nonmetals are also gases at room temperature, with the exception of bromine, which is a liquid. For example, oxygen is a very common nonmetal that we kind of rely on to live, and is typically found as a gas. Nonmetals don't allow either heat or electricity to flow through them very easily. They're insulators. For example, heat does not pass easily through the air. Air is a mixture of several nonmetal gases, such as oxygen and mostly nitrogen. For this reason, air pockets are often built into jackets, buildings, and other objects that are intended to keep people warm. The air pockets insulate the objects from the cold. Several elements lie in a diagonal line, the one that we've already looked at, that separate the metals from the nonmetals on the periodic table. These elements are the metalloids, and they mark the transition from metallic to nonmetallic. They're boron, silicon, germanium, arsenic, antimony, and tellurium. And some scientists also include polonium and astatine as metalloids. As long as you remember the metalloids are along that dark stair-step line, you'll be fine. Metalloids lie between the metals and the nonmetals and can have properties of both. Some common physical properties of metalloids is that they can be either shiny or dull. Most of them have a little bit of sheen, a little bit of luster to them. Metalloids can be malleable and ductile like metals, but not to the same extent. Some are actually brittle, like the nonmetals. Metalloids have intermediate heat and electrical conductivity. They don't conduct as effectively as metals, but they're not insulators either, like the nonmetals. Often metalloids are known as semiconductors, like germanium and silicon. And we use semiconductors a lot in technology, like your cell phone or the computer that you're using to watch the video, because they only conduct electricity at certain temperatures. And so we can control when a current passes through silicon, for example, or we can control when we don't want an electrical current to pass through. Metals, nonmetals, and metalloids are just one more way of categorizing or arranging elements on the periodic table. Thanks for watching.